procedures on the lathe. As you can see, overview of this particular lathe, I removed quite a bit of the components in order to make the Thompson rods very accessible. This is what we're going to be concerned with. We want to verify the parallelism of the Thompson rods in the two axes. When I say the two axes, I mean this axis parallel to the bed, the tabletop, and this axis, and then also across the width of the machine that they run parallel to the central key slot in your bed. You might take a look at what I've done to my tailstock. I've taken the top half off, and I'm going to be using the bottom half as the mounting point for my magnetic basin indicator, and it will allow me then to slide back and forth the length of the bed, stopping at each of these points where the Thompson rods are fastened, so that I can verify. These are the points that if I have to make adjustments, shimming or pushing on the rods, these are the connecting points, so this is where I'll do it. So I'll be taking my primary indicator readings there. Because of the weight involved with the headstock, it would be really nice if it was taken clear off of the lathe. Some people will be able to deal with that, some won't. What I want to do now is demonstrate how you can get around that without totally removing your headstock. We can pull it back far enough that it'll be out of your way. It's going to make you do some extra things with your indicator, but it'll keep you from having to lift that weight clear off the lathe bed, yet it'll move it out of your way enough to make this end of the Thompson rods more accessible. So you can see we've got a mounting point here, and on the other side of the bed, same way, there's a mounting point that can be adjusted. So in the center of your headstock, inside here, and it's going to be difficult for you to see that in the video, but there are two Allen cap bolts, and they require use of a 5/16 Allen wrench. Okay, they're the only two in there that take a wrench that large. If you can loosen both of those, that's the clamping bolts that hold the headstock onto the bed. You can loosen both of those, and then leaving your wrench in the one closest to the work into your spindle, we should be able to slide our headstock back. And being careful to keep that, this will be a visual alignment for you. You want to keep that a couple of inches up onto the end of the bed yet, so that you've got that the T-nut that's underneath here inside the box frame still firmly engaged. If you go too far, then the whole unit's going to try and tip off the end of the bed. But I'll just slowly slide it back. Now, some of you are going to find that your headstocks are very difficult to move. It's been a couple of years since they were assembled. They're going to be stuck together. See, now I can just lightly rock that back, and I can still feel that that T-nut is holding. That's kind of another indication for you that you're still safe. Well, at that point, I'll lift it back up and tighten that bolt back down now, so that I've got my headstock hanging off the end of the bedways here, but it's fastened securely so I don't inadvertently bump it and knock this entire mass off onto the floor. Okay. Now, you'll also notice that I've got the lead screw assembly out of this lathe. The entire carriage has been taken off. Back here on the back of the headstock is where the tracing template rack would mount. I've removed that. With the idea in mind, I want the Thompson rods to be as absolutely accessible as possible. I'm also kind of looking at now are some of the major components that I've removed off the lathe to make the Thompson rods more accessible. Of course, probably the first and easiest item to remove is the tailstock. It'd be a matter of loosening the locking nut on it and then just sliding it out of the T-slot in the bedway through the back of the bed. At that point, then, probably best to remove the template rack. It mounts against the headstock with two bolts here, and then at the other end, on the Thompson rod support bearing bar, there's two cap screws that come down through here. So those 4 cap screws removed allow you to lift that out probably want to remove these two first, and they would continue to rest on the bearing bar, and then remove the two in the headstock, and you'll have to support the weight of it when you do that. The overhead drive support rod, you notice this area here, there are 3 cap screws that come down through the top of the carriage plate into this. I removed this as an assembly. It's a little awkward, not extremely heavy, but I removed the outer 2 screws and then the third center screw and just lowered that down below the carriage as an assembly. Then you can see that I've got the lead screw assembly out with the apron and lead screw intact. 3 cap screws coming down through the top of the carriage plate, attach the apron to the bottom side of the carriage plate. In this case, one end or the other bearing plate, and preferably the one at the tailstock, would be removed. The long bearing bar, that would be removed so that this whole assembly then could just be slid out from underneath the carriage. And then also I unbolted the carriage from the Thompson ball bushing blocks, and I've taken those off to get them out of the way for the alignment procedure. You can work around that. You could leave those on, slide all of them, the pair, there'll be a pair on each rod. You can slide it to one end, work around them. It requires a little more bouncing up and down as far as lifting and lowering your indicator unit. So for ease of making the tape, I've removed those also. Okay, with the components removed from the lathe that we just illustrated, one of the first things you're going to notice is that at each one of these perch assemblies you have a pair of little roll pins that pin the Thompson support to the perch. At this point, we want to just leave all of that intact. Initially, we want to check and find out where we are. The ideal circumstance is that using this as an indicating base, sliding along our bed with our indicator on top of the rods, we'll find that both this front rod and the rear Thompson rod are parallel to the bed and parallel to each other in the same plane within 1/1000th of an inch everywhere that we look at it. We also then will want to know if they are parallel to this key slot in this axis. As we look across the bed this way and slide through, are they parallel, and are they equally spaced from this key slot to this rod, from this key slot to this rod? Ideally, that was the goal, that this was everything was symmetric about the center line on our Thompson rods. What I find is it helps to make just a little sketch, and this just illustrates my 2 Thompson rods, just 2 little tubular sketches. If I want, I can mark this as tailstock in and this headstock in, just for my own clarification, so I can keep track of which is which. Okay, so in preparation for doing all that, you'll notice that I've got this bearing bar back on. One of the differences you'll see in this case, I've got a couple of screws in place of the Allen bolts are there because I was in the process of aligning this machine and am in the process of redoweling this bearing bar. On yours, after you've removed, if you choose to remove the Thompson bushing blocks, put this back on, dowel pins and all. You'll find 2 1/4-inch dowel pins in here, and then the 2 5/16 cap screws. There are 2 set screws, one on top of each of the Thompson rods that you had to loosen up in order to take this off and remove your lead screw assembly. Put all that back as it was, because we want to know where we're at right now on your lathe. Is it an aligned lathe or not? Okay, before we even start with the indicator, of course, the first thing we need to find out is whether our bed is in a normal state or a twisted state. I've got a couple examples of levels out of my toolbox here. These are off my combination square. This unit is a protractor unit, and the spirit level is adjustable. And this is, of course, just the 45 combination head with the 45 and 90, and it's got a fixed spirit bubble in it Either one is acceptable if you have a good carpenter's level, torpedo level. All of these will be adequate, because what we're looking for is not so much that your machine is level to the world as that at this end, our headstock end, and at our tailstock end, it's level to each other, that we're not sitting here twisted. And ideally, once, if I use this type of level, then I would come down here and adjust this, through loosening my screws, I would adjust this till I had a level reading. Then I would transfer my level to the tailstock end, and hopefully it would match. If it doesn't, then you need to determine which way it's off and shim your lathe accordingly. Now, on the later model lathes, we did a little better job anticipating. In this area, on each of the mounting pads, there is a jack screw, an Allen set screw, where you can loosen right through the center of the bed here at the tailstock end, and through the center of the bed at the headstock end. There is a bolt and a nut that require a 3/4 inch wrench. Those can be loosened, and then the jack screws can be tweaked to bring the bed into level. For those of you who have machines 2 through 15, you'll find that what I've done on this lathe is to use, since I'm setting on vibration pads between the floor and the lathe, I took a chisel and sharpened it to a fine point. I loosened that bolt, and underneath the edge of the pad here, whichever side was off, I drove that in, and to where I had a gap to work with, and I used some of these wooden tapered builder shims. And I did it at the head and at the tail, and I worked on those until I got that natural state that I was looking for. I determined how accurate it was by taking my level, and when I was at this end, I had a specific setting at the headstock end. When I moved to the tailstock end, I got it as close as I could, and then I took a 2000 shim and worked on that level until when I put a 2000 shim under the low end of it, that was enough to bring it up to level. That was the most error that I was looking for, was within 2000. So rather than trying to center the bubble, I intentionally shoved the bubble to one specific graduation mark, so that I had the bubble lined at that graduation mark on this end, and then I got the other end level enough that the most I had to put under it was 2000s to bring that in. That should be an acceptable level for you. You shouldn't, that would remove enough twist that you shouldn't have a binding on your lathe. Okay, so after, that's one of the first things you want to check. And if you find that you're twisted, then that's the point. You want to stop the tape, and you want to work on your leveling until you've got the twist out of your bed. Now, you can either drive wedges between the feet and the floor, or you can try to drive wedges between the top of the leg and the mounting pad here. It would by far be easiest to wedge at the floor level. You'll find that there's a pretty snug fit between the dowel pin that holds this leg, the leg and the pad together. If you've got a facility to jack it up, you can take a rubber mallet and tap on the bottom of on the top of the foot down here, tap in this area to jar that down to help give you some wedging room here if you elect to try to wedge between the top of the leg and the bed for your leveling. Couple of ways of getting there, but you will find that your legs fit quite snug on these dowel pins. So it won't be a matter of just driving a wedge in there. You've got to overcome that fit first. So you might try blocking your lathe up a little bit, tap the legs down, and then you've got some air space to work with here. But like I say, by far it would be the easiest just to wedge between the feet and the floor from the standpoint of accessibility. And then once you've got it level, then you can take the chisel and trim the extra ends off the wedges so that you're not stumbling over those as you walk around your lathe, and they're not visually deterred from the appearance of your lathe. Okay, so now that we've got the machine leveled, like I say, I'd already leveled this machine, so we won't have to do that. Now that you've verified that your machine either is or isn't in a natural state and have done what you need to take the twist out, we want to do just a preliminary check and find out where are we at as far as parallelism. Okay, now this gets us back to the base of the tailstock. You can see I just have my magnetic base laid across the cross key on the tailstock base. I set it back down on the lathe. Now one of the first things I want you to do in doing this is I want you to press on the corners, the opposing corners, and make sure that you do not have a rocking condition. Okay? Ideally you won't have that. If you do, then as you go through this, you will want to maintain pressure on whichever, you select a corner. If it rocks at all, you select a corner, hold down on that, and when you zero your indicator, and always when you're taking the reading, then be holding that corner down if that was the case, or the other corner. But ideally, there won't be a rocking sensation here at all. I don't have that in this condition. I'm trying to cover all the bases here, so I'm talking about some conditions that hopefully don't exist. If they do, there are ways around it. And if you do have a tailstock base that rocks, then by all means, we can rectify that for you. All right, now this is the type of indicator I'm using. A travel type, or the 1-inch dial type travel indicator, works just as well. This is just real convenient. It's a little stirrup, last word. Auto mechanic shops refer to these as outer round gauges. These are fairly accessible. I would imagine that by now most of you have acquired one of your own. We need to pick a point. Does it make any difference where we start? We need to pick a point and find out. In this case, I'm setting my indicator right over the top of this perch. I'm loading about half the travel of the indicator. This indicator has 30 thousandths travel, and I'm using about half of that to set my 0 point. Now notice I've got the indicator projected this way. We'll slide ahead, and we'll want to get just as far up there as we can. Now, I can get a little bit more by stretching this rod out. Try to keep my hands out of the way of the rods and stuff. Notice how I've reached out a little further with it now. Ideally, we'll take our readings as close to the mounting points as possible. And once again, we'll get our indicator reading. Just arbitrarily, I'll set a 0 there. Go back to my sketch. I had headstock and tailstock. All right, I've got 1, 2, 3, 4, 5 positions that I'm going to take readings at. So I can just mark an X down here and just divide this off along something along that line to help me keep track of them, or I can number that as number 1, 2, 3, 4, 5. Okay, I zeroed, if I numbered it, this is 1, this is 2. I zeroed it 2, so I would come right on top here and mark a 0. It slides through, so I know that was my indicator 0 reading. Now I'll slide my tailstock base forward. Now, when you're coming up to the headstock, be careful and don't bang it. If you bang into the headstock, then chances are you'll shock your indicator and change your 0 reading. So come up, within pencil width of the headstock so that you don't disrupt anything. Either pushed, you will find there is some clearance in the T-slot here, in the bed and in the tailstock. So develop the habit early on of either pushing that away from you or pulling it towards you at all times when you stop to take a reading. That way you know that everything's set in a parallel state. See, ideally you'll have your indicator so that you found the highest point of this arc created by the circumference of the Thompson shaft. Try to get right on top of the center of it. That's where you get the most accurate reading. Okay, so there's only going to be like 2 thousandths clearance here, but you're taking a single point on an arc, and it will affect the truth of the indicator. If you push it this way one time and this way the next time, it'll start adding up on your indicator reading. So, like I said, develop the habit either of always pushing it towards you, or pulling it towards you or pushing it away, but all the readings will be taken in that attitude. Okay, at this point, then just note what the indicator reading is and record it as either a plus or a minus value and how much that's off. Okay, let's come back and let's stop at position number 2 and re-verify that our indicator still reads 0. I mean, this is where we zeroed it at. If for some reason it's not on 0, then we need to stop and find out what happened. Did we bang into the headstock and shock it? Double check again to make sure that you don't have rock here. This should be sitting down flat on top of your lathe bed. Make sure that you've got the tailstock base reoriented either towards you or away from you, however you had it the first time. Okay? Re-zero, go back up here, get a reading, come back. You should, unless you've got some dirt underneath the base, everything should repeat here again. You should have a 0 reading. And you can always lift the base up and check and make sure that everything's wiped clean. Make sure you wipe clean here. Feel your bed for ding. As you're sliding this along, if you feel a ding from maybe having dropped the tool or something, then take a flat file and just lightly file it to remove the high spot, or take a stone and deburr the top of your bed so that you're not running over lumps, because that's going to affect your indicator readings. Okay, we're going to operate under the supposition that having zeroed here, taking a reading here, and then coming back, we were at 0, so now we'll go on to position 3. We'll stop here. Again, reorient the tailstock base towards or away, whichever was the situation here. We duplicate that here, and again, let's just note the reading, plus or minus from 0. We'll do that at this next position. Now you'll notice that I'm going to start getting in trouble the way my indicator is set, because I can't get my indicator back here close to the bearing support where I'd like to have it. No big deal. Note what your reading is at this final station, okay? That's station number 4. You slide it back down out of the way, turn around, and re-pick up station number 4 at the same indicator reading, okay? Tweak your indicator up and down here to see, like if it was +2, reduplicate that +2. Once accomplishing that, let's slide back to position number 3. Check your sheet again, your little setup sketch. If it was at +2 or whatever its reading was, it should be there again. So that means then that the 0 point of your indicator is still at truth to this position, the very 0 position. Now you can proceed beyond station 4, checkpoint 4, come out to the end and verify where you're at. Okay? At that point, I want to come back down here to station number 1, where we'd set our, actually be station number 2, but the first point that we had zeroed at, center your magnetic base, and then let's move our indicator back up here over it where we can get a 0 reading again. If you can't reach it, if you move the rod out so far that you can't reach it without hitting the headstock, then make whatever adjustment you have to here to get back to your 0 point. And you push it away from you, pull it towards you, make sure on the high point, and very gently and carefully tilt the base up. You should be able to turn that right around, set it back down into the slot, okay, and set your indicator right over the opposing mounting point for the rear Thompson rod. Ideal circumstance is that you would have found no more than 1/1000th variation in the height of any of these 5 positions at the front, and you'll find that the rear position duplicates 0. That's ideal. That's what we're going to shoot for. Okay? Irregardless whether it did or not, we'll take a recording of what that was, go through the same process. We've got a perch. The camera won't be able to see it because of the headstock. There's another mounting perch right up here, which is opposite the first station on the front rod. So again, you project your indicator forward if you need to. After you've got a reading here, if you need to move it, lengthen it, do whatever you have to so that you can reach up there, just like we did on the other side. And then let's go back through the same procedure on this side, just recording at each station, plus and minus readings from 0. When we get to this end, we'll duplicate the procedure of turning around, resetting at a known position, can be at any one of them that we'd already recorded, duplicate the indicator reading plus or minus, reach to the end, okay? That tells us the parallel plane. We now know where we're at, okay? The other parallel attitude that we want to see is that these rods are running parallel to the slot. Okay, so that's the next part of the project. So I'll reorient my indicator base. I'm going to come back up in this zone since I used number 2 station as the zeroing point the first time round. I'll do my setup there so you can see how we're going to find out. Now here's where it really becomes critical that we orient the direction. In this case, I'm going to be pulling it towards me, away from the rod, and then when I come to this side, I'll be doing the same thing. I'll be pushing it away, the base of the tailstock away from the rod. All right, so now we'll reorient the indicator so that the needle being the highest point that approaches the shaft, find the center line of the shaft and give it a reading on our indicator. Then pull the base back, zero our indicator. Now it's going to be a little more difficult in this attitude to reach behind there. But ideally we get right up by it. You can still do it. Pick a zero reading, you can go through and check everything else and then come back and get that tough spot at the last if you want. That would save you having to do a lot of indicator changing, because with this setup, okay, we're at a 0 point, we would mark that again on our sketch, and in this case, instead where I had been marking right on top of the rod in the sketch, now I've marked to the side of it, write my readings down to the side here. That way I can differentiate which of the readings is which when I actually go to analyze this setup sketch. Okay, so now I would record my 0 point, I'd come down to the next station, pulling the base this direction, record again the reading, go through this all the way down to the end. Now when you're down at this end, be careful that the key slot on your tailstock doesn't disengage. You've got a short segment of key built into your tailstock base at this end and a short piece at that end. You need to keep both of those engaged with that T-slot. If you lose one, then you'll get a false reading on your indicator because it'll give you a little bit more slack. But at any rate, having taken those 4 positions, now I can again gently raise my base up, turn it around. I'm going to start back here at my 0 point. This is where I zero my indicator on the other side. Gently set it back in, pushing it away. Yep, the machine was originally assembled in a symmetric manner. This rod then should have a 0 reading, the same as that one did. Okay, now we go back through these 4 stations that are readily accessible. Again, recording plus or minus readings from our original 0 point. What I anticipate some of you will see is that as you get to this tailstock end, it will radically move off center. If some of the problems exist that I suspect, you're going to see this either swing away from you or towards you a considerable amount. I'm talking in the range of maybe 10 thousandths of an inch being off center. Okay, now let's go back. We've recorded the 4 most accessible readings on the front, the 4 most accessible readings on the back rod. We know where they are as far as being centered. Let me quickly demonstrate how you're going to use this indicator setup to reach that tough one up on each side of the headstock. We follow basically the same procedure we did for the top reading. We'll come around here and we'll crank our mag base and indicator around to where we can really stretch out and reach with it. We'll reach right up beside the headstock with it here. And it won't get us exactly to the end of it, but it'll get us close enough to it that we'll be comfortable with making adjustments from it. Okay, now in this case, I would re-zero my indicator then as I slide it up past, see, I can get back within an inch or two of the end, and that's adequate. But that'll tell you if this bearing is in the right place or not. And now, having done all this, we've gone through and we've verified what we've got. If in doing this we find that we are out of parallel more than 1/1000, this will be the point where we'll start adjusting. You're going to have to go through each one of these stations with a small punch and knock these little roll pins out if you find that you need to adjust. Whether you need to adjust for height or for width here, you're going to have to get the roll pins out anyway, and chances are you're not ever going to bother putting them back. There would be no sense in going through the work of re-roll pinning those. Once we've got it aligned, then, that way down the road, if you want to do an annual alignment check and you need to tweak it a little bit for one reason or another, you don't have to mess with those roll pins. Okay, so knock the roll pins out of each of the perch assemblies. Come to the rear bearing block, and again, in this case, I've removed the dowel pins here, and I've replaced the 5/16 cap screws that were in that with 1/4 inch bolts that just go all the way through, and flat washers. And what I've done is I've let the setting that the Thompson shafts have at this perch zone here control where it's going to be here. In other words, if there's this curve condition is there that I suspect might be on some of the lathes, as soon as you take those dowel pins out and those bolts out, it will try to align itself. In other words, it'll go to the natural state that it's at. Some considerations in the height adjustment. That's what I would approach first, would be shimming for the height. The things that are readily changeable, of course, are the position of these valves. What we're going to do is, once we've got everything realigned, centered position, we're going to ream those dowel holes with a tapered reamer and put new pins in their tapered pins. So height adjustment, don't start this as your 0 point at this end, because that's going to be the easiest place to change. I would suggest that you pick this zone, or as close to it as you can, as your 0 point. We can shim here. We can shim under each one of these stations. So, go back to this station and check 0 and then see if this one goes up. If this one is higher, then reset your indicator and make that your 0 point, and shim all the others up to it. If you set the lowest spot as 0, then you're faced with the problem of, well, how do I remove stock off the bottom of that to get it down to 0? You don't want to do that. You want to find the highest point of all of these positions that we checked, except for the last two here. Don't use those. To find the highest point of each of these other positions, and that's your 0 point, and everything else can be shimmed up to it. Now, what we'll be doing is sending some little donut shims along of a variety of thicknesses, and this is what you'll do your shimming with. They'll work quite well for you. You'll notice that each of these perches have a 1/4 inch Allen bolt coming in through the bottom, and they thread up into the Thompson rod. Okay, so you want to take the bolt out, slide the perch off, and then I'm going to recommend that you scrape and file any paint from overspray that was in on the aluminum perch. Make sure that it's clean. Take a razor blade and scrape the paint off the bottom of the aluminum perch. The very front edge of the steel perch as well into the lathe bed will have a little strip of black paint. Scrape that clean, and then at the back edge where the perch sat, there will be a margin of paint there. Move that back a little ways. Give yourself some room to work. Lay a good sharp file on there and flat file everything smooth. That way, as you're working with placing the shims between the perch and the aluminum piece that the Thompson rod sets on, you don't have to worry about getting shim and paint together. You want to make sure, because this is going to be moved to a new position. See, I had all that pinned in place when it was painted. Now, it won't necessarily go back exactly the same, so you could get some false readings if you don't get that paint cleaned off. Okay, so pick either the front Thompson rod or the rear Thompson rod and go through and clean each of these stations so that you know there's no paint under. Do the same thing here. There are 2 Allen cap screws that come down through the top of this bar. You've got an Allen screw here, set screw here, clamped to the Thompson rod. That can be loosened up. These 2 bolts can be taken out. And then this bearing box slides off the end of the lathe. And again, make sure that it's clean, its perch surface is clean. You know, wipe it all down and then slide it back in position. Then let's, you know, if that's going to be your 0 point, if that was the absolute highest of the other 8 perch points, then, you know, get your indicator 0 there, come down one at a time and work with these shims. The shims will be in 5,000s, 3,000s, and 2,000s increments. And that should get you to the point where you can get everything within the thousands on height. Bear in mind now, if this is your 0 point, as I suspect it will be, make sure that it is bolted tight. After you've cleaned it, put it back on, bearing block back on. The lateral movement that's in the bolt holes won't hurt you. You don't have to worry about that. You just get it back up on there and clamp it down tight. When you come to this station, you slide the first to the side, put your donut shim underneath. You'll have your indicator reading on top here, remember. You'll be looking at the top, looking at the parallelism. So your indicator will be something similar to this. You're looking for a 0 reading. Having zeroed here, you're looking for a 0 reading here. Move your indicator over out of the way so that you don't bang it. Slide your shim in, tighten the cap screw snugly. If you don't, then you're going to get erroneous readings. We go through all of our stations doing that. And at the very last here, see that the Thompson rods are basically, you leave these screws loose. And as we shim in these earlier zones, then the Thompson rod basically will keep lifting or lowering this bearing bar as needed. But at the very last, you'll find that from this point to this point, you can flex that. So you will make a final adjustment out here by either pressing down or raising up, and then snug, put some pressure on your bolts here to hold that in position. Okay, well, having done that on the front Thompson rod, then you'll repeat that process on the back. Remember, I always showed you your indicator, you've got it zeroed. You just gently lift up, reverse it, set it down without resetting your indicator, and then start working this rod back to the same 0 point. You want both these rods parallel but on the same center line plane. In other words, you don't want, if you have this rod higher or lower than this rod, then that will affect how well the leaf screw is able to couple through the drivetrain. You'll be in a tilt condition and it starts throwing this relationship of these 2 bores, starts throwing them out of truth and creates a binding condition. These are some of the problems that I've encountered with both with this machine and the other one that I'm experimenting with on final assembly processes. Okay, having accomplished the parallel adjustment as far as having this Thompson rod and that one parallel to the top of the bed in the horizontal plane and on the same center line with each other, now we're faced with the problem of centering our Thompson rods to the lathe bed. Now, observe at this end, the spacing between the 2 Thompson rods is controlled right here. There's a set of bored holes in this bearing plate. That holds the distance apart. Okay. If everything were perfect, you would be able to take your indicator, again set it to an edge reading with your base pushed away from you, pulled toward you, oriented. Pick it up, reverse it, set it down on the other side, and you should have a 0 reading. I'm not concerned with what that real width is. You don't need to worry about measuring that. What you want is this assembly centered to that slot. Okay, so ideally you would start at this end to get an idea how far off you are, and then you pick one, zero, see how close you are to being centered. You may find that you can't push it enough to get it centered until you come to one of the next stations and break the bolts loose again and then help it along. So, if it's off 5 or 6 thousandths, you may find it difficult to flex both of these Thompson rods enough to get a true zero reading at each of these points. So move to the next station, break both the cap screws loose, but you're really just working one end at a time. So you're breaking both loose here, then flex it over so that you're getting a more accurate reading here, and then snug them down, and then pick either the front rod or the back rod. When you're satisfied that you're basically within a couple of thousandths, then select either the front Thompson rod or the rear Thompson rod and go through the rest of the stations, pushing and pulling at each station. Now remember, you've already shimmed the height, so you don't have to worry about losing your truth of setting there. As long as you tighten the bolt back down snug, that shim will bring it back to truth of reading. So no problem there as far as losing your parallelism, but you work down this side, getting this rod just as straight as you can. Now, you'll have to take, you do your adjustments at each of these stations. Now, you may observe some slight variation between stations. There's just not a lot without having a solid perch the whole length that can be done about that. Some of the Thompson rods will have a little bit of flex in them that others don't. My experience at this point has been that isn't of any great concern unless it is radically bent, and it should not be, because these are hardened rods. You'll see, at the most, you'll see 1,000th fluctuation as you go from this solid mounting point to this solid mounting point. As wide as we have the bearing set up on the carriage top, the motion should absorb that, and it really shouldn't show up in your cutting of your workpiece. Okay, having aligned this front, let's say we selected the front shaft, having gone through and got in each of these positions within 1,000ths of our first position, we'll reverse our indicator and come back through the rear Thompson rod, do the same thing, and then come back and do a final reading here, verifying that it is centered, front shaft, back shaft, snug these down, go back to final reading on each side, do the final tweak on it, and then the very last thing you'll have to do before you're prepared to do any work on that rod is to verify this height. Now this gets a little tricky sometimes on getting the height on that, and it comes in handy to have a second indicator. The reason I say that, you'll find sometimes that in the process now of having moved it across this axis, we'll have lost our final height setting in this axis. So now what I'm going to do, the last thing that I had done was to make sure that I was parallel on this axis and centered. So let's go back on the height setting and find out where it is. We'll take a zero reading here and set our indicator at 0 and project out to the end of the bed adjustment here. Come out here and verify that. Now, if there's an error at this point, then ideally I would take another indicator and either attach it down here and set it on the side, set it somewhere where it's out of the way, the magnetic base, and then touch your indicator to the edge here, since this is what you last adjusted and don't want to lose control of. And then get a zero reading on that. Then as you tap this with a soft hammer, if the zero reading start changes here, then it's a matter of keeping up the other direction at the same time. So you might end up lightly striking down and lightly striking over until you can travel across it with your zero reading here again, and you haven't lost your zero reading here. Then at that point you'll need to verify that you have a zero reading on the rear rod, again in the horizontal plane. Remember, these two rods are tied together, so as long as you didn't lose your zero reading on the edge of this one, you won't have lost it on the edge of this one once you re-attain a level reading here. So you would reverse your indicator and go back through the process of finding a 0 point and checking the, parallelism of the height of your Thompson rod. We'll go through here, we'll get a 0 real quickly. Then we would reach back and verify. Now, if this one was off a little bit, again, then we need to tweak it just a little. And you're going to have to go back and forth till you've got those within that 1/1000th tolerance. And as long as this indicator hasn't lost its 0 reading, then you've still got your parallelism in the other axis. That point, okay, once we've achieved the alignment, we've got our Thompson rod centered, running parallel to the bedways, then we need to come back to the end of our machine and take a look and see what the condition is where our original dowel holes were here to pin the bearing bar on the back of the bed. More than likely, they will not line up anymore. You can visually sight through there. You can try to put the original 1/4" dowel in. I think you'll find that they won't go in. In that case, we're going to provide you with some tapered pins. We're using a number 5. Now this particular tapered pin that I'm setting on the end of the lathe here is a little shorter than the ones that you'll be getting. This is 1 1/16 long, and we'll be providing 1 1/4", but there'll be a number 5. They'll be the same diameter here at the large end of the taper. That's 289 thousandths, okay, for the number 5 tapered pin, and gradually tapers smaller at this end. Having had 1/4" holes in here originally, we're going to need to drill through to clean them up, and then we'll ream those with a tapered reamer, and I'll attempt to hold that against that dark background so you can see that it's a much smaller diameter here than it is here. Now if you'll look, compare the two here, there is a point on that tapered reamer where the diameter of the reamer and the large diameter of the pin will match. So if you started just reaming this hole without drilling it, if you could put the reamer all the way through both the hole in the bearing plate and the hole in the back of the lathe, then theoretically you could start reaming, having mark on the reamer where this largest diameter is, and when you got to that point, stop, and that's how far that pin would drive in. You'll find that's going to be a lot of reaming though. So what you'll want to do is drill through first. Probably a happy medium on that is like a 17/64 drill. If you were to drill through both the holes with a 17/64 drill, then start reaming, and you'll want to hold the reamer in a tap handle like this, and a T handle is commonly referred to. It grips the square shank on the reamer, gives you the capability of reaming forward, and then as you're turning, I'm exerting forward pressure, pushing the tapered reamer into the hole and turning, and then as I'm turning, I'll withdraw, and the chips will be in the reamer, and then you can just lightly blow them out or wipe them out with a rag. Be careful of wiping with your fingers. These flutes do get sharp, and if you get grabbing it and wiping too hard, you'll end up with cuts. So if you're going to wipe it, use like a little paintbrush or something, and brush the chips out. And if you have access to some cutting oil or some light oil of some kind, that'll help the cutting action of the reamer, keep it from galled up. But at any rate, ideally, you want to tape, after you've drilled the 17/64 hole, re-drill these two at 17/64, then run your tapered reamer in until you can visually see that at both sides here, the reamer fills the hole and is cutting at both this end and this end. You can visually look through the hole and you'll see a smooth tapered hole. That's the point, that you have to have, otherwise the pin won't register both pieces simultaneously. But once you've reached that point and you haven't gone so far that this large diameter just falls through. Now you'll notice when I put this one in that I intentionally went deep on this one because it's a shorter pin. That's the reason I'm ordering longer ones for the repair. But at any rate, this being a tapered pin, it will go to a point and then stop. And then if I took a pin punch and a ball peen hammer, just lightly seat it, then that locks those two together. Like I say, with the longer pins we're going to provide, you'll probably have a slight amount of pin sticking out the back, which is fine. There should be no problem for you. That would be the ideal circumstance. You really don't want to lose your pin inside the hole like that one is. Although that's not protruding all the way through the back side, so that would hold the part adequately, the two parts together adequately, a pair of those pins. But we'll give you longer ones so that you should be able to see the pin at both sides of it here. And like I said, then just take a pin punch and a small ball peen hammer, just lightly seat the dowels. That then will register the bearing bar to the back of the lathe, which should hold all your alignments. Then you can take these 2 1/4-inch bolts out that we placed through here temporarily, and again visually inspect to see if you're going to be able to reuse the 5/16 cap screws that were originally provided. If there was very much error in the location of this bearing bar, then you probably won't be able to use those, and you'll probably have to stay with this kind of an arrangement. You can turn it around, get some 1/4-inch hex-headed bolts, or turn it around, put the nuts on the inside so that you don't have anything hanging out here to catch your clothes as you walk by. But these will do. I mean, this would be adequate. The 1/4-inch bolts through those holes with the flat washers would be more than adequate, because the dowel pins are actually holding the position, and all the bolts are doing is keeping it up snug to the end of the lathe. You got a pair of set screws here that also help fasten it in position. So, like I say, if you can't start the 5/16 Allen cap screws, then put your 1/4-inch bolts back through. Put the head out and the nuts inside. There's room to reach around underneath your lathe. You can get up through the cabinet, get your hand in here to work on getting the nuts, get a wrench on them. Same way, when you get ready to start your reassembly, this is the bearing bar you want to take off, and you'll slide everything on from this end, leaving that end alone since it doesn't dowel. With this set of dowels now, this should register it. So in order to take those back out, you will need to come underneath with a pin punch. You might be able to get through in an attitude like this with a long pin punch, but be about as well to come from underneath. And once you broke the taper loose, and the pins will come right out. Then you can take your bolts out, slide your bearing bar off, and start your reassembly process. Hopefully this will resolve some of the problems you've had as far as getting rid of the twist and the misalignments. What I've seen on the 2 machines, this one and the other machine I've got here, that's resolved quite a few of the problems as far as the smoothness of the action, in addition of the other things that we're doing to the lead screw and that drive assembly.